All right, y'all. I'm gonna dive right into this. So today we're gonna be talking about algebra reasoning and proofs. All right. And so the goal here is to give you a deeper understanding of how this works. You should already know how to solve algebraic reasoning type problems. That's simply just taking an equation, solving for x, or solving for y, solving for whatever variable that you're looking at. And so today we're actually going to take that a step further with our notes and being able to gain a deeper understanding of that. So the essential question I'm going to ask you is, what is a proof and how can I use it algebraically? So when you're thinking about a proof, think about it in terms of something that we're trying to uncover, a mystery that we're trying to solve. And it needs to be something that makes sense. It needs to be something that we can break down and be able to see. And so by the end of this particular video, my hope is that you have a deeper understanding of the concept and importance of mathematical proofs, understand and apply the properties of equality, and be able to solve linear equations using different algebraic properties. So let's dive into the properties and what they actually are. And so this first property right here, sorry, y'all. This first property that we see here, it says let A and B be real numbers. So if A is equal to B, then A plus C is equal to B plus C. So what essentially are we doing there? What you'll notice here is if the original problem I have is A is equal to B, and we end up having this plus C on the left and this plus C on the right, we call that the addition property. And so all the addition property is, I'm just going to minimize this for a second. Just basically means that what we do to one side of the equation, we do to the other. We're adding into that particular property. So in the second, if A is equal to B, then A minus C is equal to B minus C. Similar to what we just saw when we added C to both sides. Now this time we're going to be subtracting C on both sides. So therefore we call that the subtraction property. And so these are concepts that you've seen many, many times before when solving. Anytime that we're trying to move a variable over to one side of the equation to the other, or a constant from one side of the equation to the other, you typically know that you do the opposite in order to move it. And so here we're just breaking it down and explaining exactly what that is. This next one, just going to move this up. Here, notice we have AC is equal to BC. Well, what operation is typically in between those? That's going to be multiplication. So we call that the multiplication property. And so, as you can see, it's pretty straightforward from here, right? Then we have the division property. And so all of these, like I said before, you've seen these, right? C cannot equal 0 because we cannot divide by 0. So here we have A divided by C is equal to B divided by C. And that's essentially what we're looking at. Now, the ones that will be new to you will be the next 4. All right. Well, technically the next 3. And so in this line here where it says A is equal to A, we call that reflexive. I want you to think about a reflection. What you see is what you get, right? Mirror. For the next one, if A is equal to B and B is equal to A, we call that the symmetric property. I'm actually going to add property to this. All of these are properties. All right, yeah, all of these here are properties. So that's the reflexive property. This is the symmetric, right? Think about mirror image. What you see on one side is what you see on the other. And then lastly, here, if A is equal to B is equal to C, then A is equal to C. So the best way to kind of think about this is, let's say that you had a product that you were selling. And that product, you gave it to someone else to sell it for you. All right. And so essentially, because you're having that other person sell their product for you, you have to pay them something in order for them to sell it, and in order for you to get it to your end customer. So if A is you, B represents the person that you're, the company that you're giving your products to sell. C represents the customer, right? If you give the products to the company and the company gives the product to the customer, what makes it so you can't sell the product from yourself to the actual customer? So essentially what we're technically doing here is, I like to say, we're removing the middleman. All right, so if A is equal to B is equal to C, then I can say that A is equal to C as well. We call that the transitive property. And so these properties here become extremely important as we move up and move further in our geometry journey, but some things that you should be familiar with. And then next we have, if A is equal to B, and A can be B substituted for B in any equation or expression. So this one kind of gives you what it is. This is really just talking about the substitution property. So if you have B is equal to A, any expression that we have, we can plug B in for that expression. And then finally, the last one, A times B plus C is equal to AB plus AC. All we essentially did was we took this A and we distribute that into the parentheses. So we multiply A times B and A times C. And so that we call the distribution property. All right. And so these are all the basic terms that you have to be familiar with when going through and looking at those. And so this next part here kind of just helps you get into that practice to get familiar with what you're looking at. And so it just talks about the different properties. You just naming the different properties for this. I'm going to skip this one and take us over to the actual proofs themselves. And so on this part here, I'm going to start with 15 so you can understand how these proofs are written. And then I'm going to make my way back to 14 so that it makes more sense. So on 15 here, we're given -5 times 7w plus 8 is equal to 30. They want us to prove that w is equal to -2. Anytime that you're writing a proof statement, the first line is always going to be the same. It's always going to be what they gave you, right? Your statement is going to be what they gave you. Your reasoning is going to be given. So what I'm going to do on this first line is I'm going to type -5 parentheses 7w plus 8 parentheses equals 30. This is what they gave me, all right? And so if I'm giving this, essentially how you will go and work this out, you would just solve this regularly, right? You'll take this, you'll try to solve for w, and by solving for w, you'll then have all of these different properties on the right-hand side that kind of goes through and explains and describes everything that you're looking at. And so the next step that we can do here is we can take this -5 and we can multiply it times everything inside the parentheses. Well, why are we multiplying it? Because that's what we call the distribution property. When I take whatever is on the outside of my parentheses and multiply it times everything on the inside. So when I do that, I end up with -35w plus or minus, doesn't really matter, a -40. And that's going to be set equal to 30. Next, as you can see, we have the addition property. And what did we say the addition property was earlier? Yeah, we're going to be adding on both sides of the equal sign. But what exactly are we going to be adding? Well, if you're solving this and working this out by hand, you will move this negative 40 from this left side to the right side. And so when you do that, we end up with negative 35W equals to 70. Now, obviously, I'm going to write this down so you can see it and be able to visualize this a little bit better. So essentially what we're doing here is we're going to be adding 40 on this side, and we're going to be adding 40 on this side. All right. Similar to how we were distributing here. Now we're going to be adding in order to get this next step here. And then the last one is division. Well, what's the last step in order to get W by itself? We have to divide. So when we're dividing, you'll notice here that W equals -2. And that's actually what we got here. It's what we just proved. And so these are the steps that you'll use when you're going through and you're working this out. Like I said, it's pretty straightforward, all in all. Just go and solve it the way that you would typically solve it. So I will actually solve this first. And then after I solve it, I go back and do the reasoning to go through and just write the steps out. So let's go to number 14 so you can understand what I'm saying. So here they gave us 3x plus 2 is equal to 23 minus 4x. And they want us to prove that x is equal to 3. And so here, when you look at these steps, all we're really doing here is just solving it like we would typically solve the problem. And as we go through and we solve it, we end up with x is equal to 3. Well, what exactly does that look like? So here, as I told you before, the first line is always going to be what? Yeah, it's going to be the given. So I'm going to write given there. That always stays the same. That's never going to change. The second line, well, what's happening from the first line to the second line? So we notice here we had a -4 on this right-hand side here. But when you look at the bottom, we have a +4 on the left-hand side, right? So what do? We move this -4 from the right-hand side of the equation to the left-hand side. Well, if I have -4x, how do I move it? I have to add. So that is why we call this the addition property. And then from there, we notice that we no longer have the 3x and the 4x. Now we have 7x. And so anytime you see this, you've heard this many, many times. This wasn't one of the properties that we talked about above, but we call that combining like terms. All right, so I'm just going to write combine like terms. So you've heard this many, many times. You've seen this many, many times, especially if you've done algebra. Anytime that we simplify something on the same side, we combine like terms. And then the next step here, we had 7x plus 2 is equal to 23. We no longer have that 7x plus 2 is equal to 23. Now we just have 7x is equal to 21. Well, what do? We got rid of this 2. Well, how do you get rid of the 2? Because it's positive, we have to do the opposite. So we're subtracting 2 on both sides. So just pretend like that's a 2. I know I don't like a 2. We're subtracting 2 on both sides. So here we call that the subtraction property. I'm hoping you are catching on to these steps, right? This is legitimately the exact same thing over and over and over. And then lastly here, we have the 7x is equal to 21. Try and get x by itself. The only step that we can do at this point is divide. So we call that the division property. And so as you go through and you're working these out, this is essentially what you're going to be looking at. So on that check your understanding work that I gave you, go through and work out those problems, work and perfect the skills, watch the video as many times as you can to try to help you understand it, and then we'll go from there. All right, take care.